day everyone, especially to you Ma'am Alma Patria. By the way, I am Crystal Shane Quijano Dangin, and for today's presentation, we're gonna tackle about our activity 6, which is the titration. So before we proceed, let us know what is the objectives of this presentation. So the first one is to have a clear understanding about titration, and the second one is to learn the purpose of titration, and the last one is to quantify acids and base reaction by titration. So without further ado, let's begin. One famous laboratory method is titration. Chemists use this method to quantify the unknown concentration of the solution by reacting it with solution of known concentration and an acid-base titration. The acid may be the solution with known concentration and reacts with the base of unknown concentration to determine his concentration or vice versa. So titration is done just like this. Suppose you have a known concentration of sodium hydroxide and you want to determine the unknown concentration of HCl, so you do the equation. You put the HCl solution of volume 50 ml in an Erlenmeyer flask and you fill the verts with sodium hydroxide solute up to the 0 mark. You need an indicator called phenolphthalein and you put 3 drops to the Erlenmeyer plus. The purpose of this indicator is for us to know the endpoint. Now, you start your titration. Several times later, you notice that there is temporary color like being changed when the sodium hydroxide solution drops. This means that we are now going to reach the endpoint. The endpoint is a permanent color change from the colorless to the light pink. When you put more sodium hydroxide exceeding the needed sodium hydroxide for the endpoint, then your solution is now overrun. Another term used in titration is equivalence point. This is the time when the amount of mole H plus ions has reacted with the same amount of mole OH plus minus ions. This appears as the temporary color change in your titration, whereas endpoint has slightly exceeds the amount minus and appears as permanent color change in your titration. You can learn more titration techniques when you have your actual titration. Actually, in reality, we cannot tell when or where the equivalence points, so we need to reach the endpoint. And the volume of sodium hydroxide used is what we use in our calculation. Here, we assume that the amount mole of sodium hydroxide from the endpoint is equal to the amount mole sodium hydroxide to equivalence for us to solve the unknown HCl concentration. So let us try solving some problems. In order to standardize an HCl solution, you put 50 ml of it in an Erlenmeyer flask with a few drops of phenolphthalein as an indicator and fill the virit with 0.15 to 4 molarity sodium hydroxide up to the 0 mark. Then you use 33.32 ml sodium hydroxide for you to reach the endpoint. So what is the concentration of HCl? First, we need to write the balance equation, so we have the volume used in integration, which is 33.32 ml. We then find the mole of sodium hydroxide, so we have then from the balance equation, we can convert from the amount more sodium hydroxide from the amount mole HCl, so we have then we can compute the concentration of HCl. So we have hence the concentration of HCl is 0.1016 molarity. So that's it. That is all for now. I hope you learned something today. So my generalization is I realized that titration is really important, especially in medical technology, because titration can be used to determine the concentration of acids, bases, and other substances in blood and urine samples. The titration is usually done automatically by a machine that is interfaced to a computer. It can do either acid-base or reduction oxidation titrations.